Hi, and welcome to Geeks for Geeks. Today, we would be discussing the problem minimum time to fulfill all orders. Now, in this problem, if you summarize this, we are given to make n donuts. Okay, and you can make this by making use of the available L chefs. Okay, now, the pattern in which the ships work is a little bit different. That is, suppose they have a rank of R, then the first dish would require R time, the next dish would require 2 hour time, and the third dish would require 3 hour time. Okay. And what do we need to do is we are given the number of donuts we need to make, we are given the amount of ships and their rank, and the time required is already given by their rank. Okay, it is not given directly, but by the rank you can tell the time by doing this hour, 2 hour, 3 hour, and you need to tell the minimum time in which these n donuts would be ready. And one more thing is that suppose I am a chef, so if I don't complete the first one, I can't go to the second one. That means I would work same simultaneously. Okay. But all the other chefs can work parallelly. That means suppose I am working, then my co-chef worker can also work. But it is not the scenario that I can make two dishes or three dishes at the same time. I can make only one dish at the same time, and my co-worker can also do the same, and we can both work at the same time. Okay. Now let us move forward to the sample test case and understand it a little bit better. So we are given that we have 4 shifts available to us and the time required is 1, 2, 3, 4. And we need to make 10 donuts. Now let us see if in 12 amount of time this is possible or not. Okay. So if we take the first chef, then he would be making one donut. The next donut he would require is 2, then 3, then 4, then 5, then 6, then 7. Now let us see how many donuts can he make in a time frame of 12. So he can make the first donut, he can make the second. So by after making the first donut, the time consumed will be 1. Okay, this is just like the prefix sum. After consuming the second donut, the time consumed would be 3. After consuming the third donut, the time consumed will be previous time consumed plus the current time consumed, 6. After consuming this one, this would be 10. And after this one, this would be 15. So in total, the first one can make only till 4 donut. So from the first chef, we can expect him to give 4 donut. Now let us see the same for the next one. So next one, the amount of time required would be 2, then 4, then 6, then 8, then 10. Let us do the prefix sum. So 2, then 6, then 12, then 20. So he can make 3 donuts. Okay. So we can expect him to bring 3 donuts. Now let us see the next one. So doing the next one, we have 3, 6, and 9. So we have 3. Here we come across 9. 9 plus 9, 18. So this would be greater. So he can make only 2 donuts. So 2 donuts. Let us see for 4. So the first would require 4. Then the next would require 8. Okay. And next would require 12, which is equal to 4. Then 4 plus 8, 12. 12 plus 12, 24. So it would require 2 donuts. So 2 donuts. 4 plus 6. 4 plus 2, 6. 6 plus 2, 8. 8 plus 3, 11. So yes, we can make more than 10 donuts. Okay. Here we are told that we can exactly make 10. We need to make exactly 10 donuts. It is written that I can just show you exactly n donuts. Okay. But it's a scenario that I can ask the chef to make one less donut and I can do the same. Okay, if it is not very specific. So yes, I can do that. So now let us try to think, how can we solve this problem? So if we just observe this, then if you take an amount of 11, okay, then as this is the minimum, so 11 is not possible. So I would just write n here. Okay, it is not possible. If you write 12, then it is possible. I would write yes. If it is 13, that means if I give the chef more time, then obviously they would be able to make that. Like suppose if I'm able to study 4 hours in one day, then in 2 hours I would definitely be able to do that. So if at 12 amount of time they can make 10 donuts, then in more than 12 I can definitely make 10 donuts. So yes, this is also possible. So if you observe, the graph is somewhat like this, that suppose we have 9, 10, 11, 12, 13, 14, 15, and we have dot 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 this side, that dot dot this side. Okay, so this side we have till this point no, 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 and all this would also be no. And if you observe this side, then this is yes, this is yes, this is yes, and all the side is also yes. So this is known as monotonous function itself. Okay, so if you're not hearing this, it's absolutely fine. Pause this video at this point and you can learn about it. So now there is one more thing that we can do about it. Okay, so see, this is the monotonous function. So what we can do is we can use a for loop to access this. That is, we would start from 0. We would check if 0 amount is sufficient. We would go to 1 if that amount is sufficient. We would go to 2 if that amount is sufficient or not. We would go to 3 if that amount is sufficient or not. How would we know that is sufficient or not? For each step, for each chef, we would find the number of them they are bringing out by writing this kind of prefix something. Okay, so yes, we can do that. We can check if it is sufficient or not. So we would start moving from 0 and we would go till the value 11 and we would be having that. At the point 12 we would be having our answer, and we can do this for all this. So now we can see, now let us see the constraint itself. So we have the first constraint as n. Okay, so suppose for checking a particular if this is sufficient or not, we would go to each of the chef. So that would be big O of n. Okay, so as n most of the time is the size of the array, but here n is the number of requirement. Okay, this is the requirement. L is the number of chef. Okay, so now let us see this. Suppose the requirement is 10 to the power 3 in the worst scenario, and the number of chef is only 1. Okay, so that would be absolutely very large in the worst scenario. Okay, so can we do better than this or not? Okay, yes, we can do better than this. Okay, that is for each point we are checking all the elements. So can we, so we are just checking if it is sufficient or not, if that is sufficient or not. So instead of that, to optimize that, we can use the concept of binary search. Now, the first question you would have in your mind is, we are just checking, and at the next point, Siddharth is telling us that we need the concept of binary search. But how does it make, but how the transition is made from for loop to binary search? So see, I have written down before the for loop that it is that this is a monotonous function. So whenever we have a monotonous function and we need to check the first point where it is valid, or the last point where it is valid, or the first invalid point or the last invalid point, and we have this kind of structure that we have, I would just show you some more examples like no, no, yes, yes, or yes, yes, no, no. Okay, if we have this kind of structure, or only yes, 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 or only no, 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 then it is known as monotonous function. And when we have this, we know that we can do a binary search on the answer. Okay, so let us move forward. So what we can do is, we have, let me write the examples of all the timings. Okay, like the, so I would just show you over there. Like the first chef would require 1 unit of time for the first movement, then 2 unit, then 3 unit, then 4 unit, then 5 unit, then 6, then 7. If we do the prefix sum, this would be 1, this would be 3, this would be 6, this would be 10, this would be 15, this would be 21, this would be 28. Let's do for 2. So we have 2. So I would just, so yellow is prefix sum and the white would be the number of elements. Okay. So 2, 4, 6, 8, 10. So we have the prefix sum as 2, 6, 12, 20, and then 30. Okay. Now let us have one more. That is for 3. We have 3, 6, 9, 12, 15. So we have the prefix sum as 3, 9, 18, then plus 12 is equals to 30. Now let's do the next prefix sum, that we have 4, 8, 12. Okay. So we have the prefix sum as 4, and then 4 plus 8 equal 12, 12 plus 12, 24. Now let us start doing how we do it. So what we would do is we would have the low value as 0 and high value as 20. So when we take the first mid out, it would be low plus high divided by 2. 0 plus 20 divided by 2 is equals to 10. So we would go and see if 10 is possible or not. So what we would do is we would see till this point 10. So that means I can make 4 donuts from the first chef. I can make 2 donuts from the second chef. I can make 2 donuts from the third chef. I can make only 1 donut from the fourth chef. So we would have the total number of donuts as 4 plus 2, 6, 6 plus 2, 8, and then 9. So 9 is not the required number. 9 is less. So if it is less, that means we need to increment the range. Okay. So if we need to increment the value of mid, then what we need to do is we need to increment the value of low. So now we would make low to 10 plus 1. Why? Mid plus 1, because mid is already checked. So mid won't be the answer. So now the mid would be 11 plus 20 divided by 2, which is equals to 31 divided by 2, which is equals to 15.5. Doing the integer division would make it just 15. So now let us check if 15 is possible or not. So if we do 15, then the first element we can do is we can make the number of donuts as 1, 2, 3, 4, 5. So 5 donuts can be made from the first chef. Then 3 donuts can be made from the second chef. Then 2 donuts can be again made from the third chef. And then 2 donuts again. That is 3 plus 2, 5. 5 plus 5, 10. This is 12. So 12 donuts I can make. So this is more than the desired number. Okay. So this means that there is a lower value that may be present. Okay. So we need to lower down the value of mid. Lower down the value of mid means we need to lower down the value of high itself. So we would make high as mid minus 1 because 15 is already checked. So 15 minus 1 is equals to 14. See how are we getting close to our answer. Okay. So now again we have 11 plus 14 divided by 2. So we have 11 plus 14, 25 divided by 2. 25 divided by 2 is equals to 12.5. So see, now we would go to 12. We would check if 12 is possible. We have already seen that 12 is possible. If 12 is possible, then it might be a case that less than 12 is also possible. So now we would make this as 11. So now 11 is not possible. So at this point, low would be greater than that and we would exit this. So see how we are getting the correct output for this. Okay. So whenever we are able to achieve the number of donuts more than the required number of donuts, we would say that yes, this is possible. Else we would try to extend the value of the mid itself. Okay. So this is how we would do binary search on the given answer. Okay. We would find if it is possible or not for each segment and we would do low and high. Okay. Now let us move to the implementation so that you have a better understanding. So now, as we know how we would check for each of the segment. So now let us first do if it is possible or not. So I would just write if it is possible. Okay, if it is possible. So we would have this as the desired number. Okay, desired number of values. This would be the n value. This is the desired number of donuts we want. And then we would have the vector int and of the cook. Okay, and then we would have the size as n, and this is the mid value. Okay, so this is the mid value. This is the time we are prescribing from the binary search. This is the size of the array, and this is the number of donuts that is required. So we would initialize the count with 0, and then we would iterate over the all the cooks. So for int I is equals to 0, I is less than n, and I plus plus. Okay. So what we would do is we would initialize c is equals to 0. And then we would say that in time is equals to the mid available to us. We would just make a copy because at each point we would be subtracting it. Okay. And then we would say that the prep time, okay, the prep time is equals to the cook of I, because in the first time, the time required is 1, then it is multiplied by 2, then it is multiplied by 3. Okay, so we do that, and then what we do is that, so we would do while till the time we have greater than equals to 0. Till time is left, we would keep consuming it. Okay, so we would say time minus is equals to the time to prepare. Okay, and then we would need to increment the preparation time, because the preparation time would increment the next time. So we would say if time is greater than equal to 0. Okay, if we are able to do that, then only we would increment this. Because why did we do this? I would say you this why. Because suppose the time required was 5 and the current time is 6. So yes, we can't do this. That is why we are telling that if after preparation we are having the zeroth value or a positive value, that means yes, that time is left, we are not going into the negative side, then we would increment the number of donuts we are making, and then we would say that the prep time is now to be increased with the cook of I. So initially suppose it is 1, next time it is 2, then next time it is 3. If it is 2, the next time it would be 4. We add the value current. So suppose this is 2, suppose cook value is equals to 2. So current prep value is equals to 2. Next time again cook value, that means 4. Then again 2 value. So this is how we would go from 1x, 2x, 3x, 4x by adding x at each point of time. Okay, understood it? Now we would go down and we would say that this is the count of the values I can do. And then what I would do is if count is greater than equal to p, that if we were able to make more donuts than the required number, we would return a true value. Else what we would do is we would just come down and we would return false. Okay, and this is done. So now here comes the binary search part, which is a little small enough. So we would initialize s is equals to 0 and the large value as a very large value, that is 1, that is 1 is 6 plus 7. We can do that. Now what we would do is we would initialize the mid. Okay, and then we would say answer is equals to -1, and you can initialize the mid inside the while loop also. Okay, that is absolutely not an issue. Small optimization. So while s is less than equal to e, while low is less than equal to high. Okay, we would do that. Then we would find mid is equals to s plus e. Then we would divide by 2 itself. Okay, and then we would ask if it is possible or not. So I would just copy this and I would say if possible n comma arr comma l comma mid. Okay, if this is possible, then we would update the answer. Okay, and we would say there might be a scenario that less than this answer is possible. So we would make high is equals to mid -1, because mid is already checked. And then we would go to the else condition and we would say s is equals to mid +1. And at the end, the last updated answer would be the minimum one. So we would return the answer variable. Just compile and run and see how many mistakes are we making. Okay, so let us make it smaller case and let us make it ARR, because I'm more accustomed to that, and let's make it as lowercase l. Yeah, I think that would be fine enough. Okay, we are getting a correct output for the sample test case. Let us try to submit this and see. Okay, so yes, we got an AC. Talking about the space complexity, we are not using any auxiliary space, we are just using variables. The space complexity is big of 1, and the time complexity is that we are iterating on each of the values. So that is nothing but big of n into log n, because due to this one. binary search time complexity. Okay, if you were here till this point of the solution, consider liking the video and leaving a comment on the video so that the reach of the video can be increased. Thank you and have a nice day.